Hola, mi clase. So, last video. Goodbye videos after today. 9.7 systems of linear and quadratic equations. So, the essential question, or what we're going to do today, is we're going to solve systems of linear and quadratic equations. We're going to graph, we're going to eliminate, and we're going to substitute. So, a linear quadratic system is a system or a set of equations that include a linear equation, so that's a straight line, and a quadratic equation, which is our parabolas, right, our U-shapes, and is represented on a graph by a single line and a parabola. So they're going to be on the same graph together. So the top two things are examples of what we would be kind of looking for. So I know it's a little hard to tell, but there's a purple line, come on pen, right here. That's my linear function. And then what we have are a green, a blue, and a red parabola to show you all the different kinds that you can have. So this, if we used the green line with the purple line, we would say it's no solution because they do not intersect anywhere. If we used the blue parabola with the purple line, we would say it's one solution because they cross in one place right here at the parabola's vertex. And if we use the red line, or parabola to the line, we would get two solutions because they cross at the two places that the parabola crosses my linear function. So then same thing over here, but now we have this negative line right here. It's still purple, and then same idea. So green is no solution because it does not cross the purple line. Blue would be one solution because it's only crossing right here. Okay. And red parabola would still be two solutions because it's, well, you can't see one of them, but it crosses here and here. Okay, so no, it's still no solution, one solution, two solutions. It's just crosses nowhere, crosses once, crosses twice. Okay, so this is a system of a parabola and a linear function. We can even split them up as, you know, y equals, I'm going to flip it as negative x squared plus 5, just so that it's in the same version we're used to. And then I'm going to make our linear function y equals x plus 3 blue, so that when I graph them, you can see them, okay? So let's go to the linear function. It's a little easier to graph. So the slope is 1, and the y-intercept is 3. So I'm going to go to 0, 3, and put my y-intercept, and then my slope is positive, so it's going to be a line like this. And it's 1, so I remember we go up 1, right 1, up 1, right 1, up 1, right 1. I'm going to put as many points as I possibly can of my linear function. And that's another reason why I'm starting with my linear function. Geez, I can't get it to draw right here. There we go. They're easier to graph, and I don't know where it's going to cross yet, so I need as many points as possible. And I'm not doing a very good job connecting these. So I'm going to cheat and get me a line, but I'm going to make it blue so that it's still the same color. All right, so there is my linear function. So now I'm going to graph my parabola. We also know its vertex is at 0, right? No adding, 5. It's also its y-intercept, so its vertex happens to be its y-intercept. It is upside down because the a is negative, and it's still just 1, so that means I can go 1, 1. And then I go back to my vertex. Remember, we go 1, 2, 1, 2, 3, 4. That's probably good on that side. And then I'm just going to make sure it mirrors it on the other side of my axis of symmetry, and I'm going to get an upside down parabola like this. And now we can see that they cross in two places. So it says, how can you graph to find the solutions? So this is a two-solution system. We technically can even find them, which is really nice. It's at 1, 4, and 2, 1. Right? We actually can find those solutions, which is really, really nice. Oh, negative 2, 1. I can count, I promise. negative. This is negative over here. Negative 2, 1. Okay? So then, since we normally, when we solve like parabolas, right, the solution, we would just say x equals 1 and x equals negative 2. And that's similar to when we were solving quadratics, right? This is the solution we were looking for. These are the points they cross at. And then this would be the solution that we're looking for, because just like quadratics, these are their, in a sense, these are their solutions, right? So when x is 1 and x is negative 2, these two will be equivalent. All right. Let's go to the next one. All right, so we're going to solve by graphing. Again, I'm going to just split them up. Y equals x squared plus 1, just so that we have them more in graphing form. Y equals x plus 3. That's really nice. It's the same exact graph as last time. I already know where its y-intercept is. It's always nice when a slope is 1. Again, I am going to cheat to draw my line. All right, so then my parabola, it has a vertex of 0, 1. Okay, that's also my axis of symmetry, right? It's a horrible axis of symmetry. It is a coefficient of 1. A is 1, so it's upright. So I'm going to go 1, 1. Go back to my vertex, 1, 2, 1, 2, 3, 4. And then I'm just going to mirror it 2 away here. And there would be my parabola. So this again has two solutions, crossing at negative 1, 2, and 2, 5. And so we would then say the solutions are negative 1 and 2. So that's the end that we're looking for, right? What is the x? Just like when we solve parabolas, we're always trying to find out what is that x. So negative 1 and 2. So what are the solutions of a system equations below? So they set them up separately this time. So what we're going to use is actually elimination for this. We have to go back to think about systems. All right, we're going to use elimination for this one. So remember, with elimination, we are trying to eliminate one of my variables. I don't really like how close these are. Maybe I can shift them. Hold on. I want to right next to them. Oh, yeah, there we go. So what I'm going to do is I'm going to basically subtract this from this. So it's kind of going to look like this. I'm going to go like this. And then I'm going to figure out what it is. Okay? So if I take y minus y, I get 0. Now, if I look, I got to be really careful. This is actually x, which is going to go with this one. And this is going to go with this one. And x squared has nothing. X squared minus nothing is just x squared. I have negative 6x minus 2x, so we should get minus 8x, right? I borrowed 6 apples from you. I'm borrowing 2 more. I need to owe you 8, right? Now this is also another tricky one. 8 take away minus 4. We need to remember what minus and minus is. It's actually a positive, so this becomes plus 12. Now we have this in quadratic form. So see, now it's just the quadratic, it's just my parabola in a sense, but we've blended them to figure out what the solution is. So we can do pretty much any method we want. I'm going to use factoring because these aren't too difficult to factor. So we'll get x, or 0 equals x, I'm looking for 12, positive 12, negative 8, so I'm going to go minus 6 and x minus 2. Right? A negative times a negative is a positive, but if I add these together, they get me negative 8. So then remember, we go x minus 6 equals 0, x minus 2 equals 0. We split them up. I do plus 6, and I get x equals 6. And I go plus 2, and I get x equals 2. So this would be two solutions. I know that they're going to cross where x is 6 and x is 2. I'm not sure where the y is. But I know it's two solutions, and their solutions are x equals 6 and x equals 2. Okay, so this is how we do elimination. Don't always just rely on the quadratic formula. We only really want to use that if we know it can't be factored or if they're really large numbers that are hard to factor. These were not difficult to factor, so I factored them. Don't forget that tool. All right, maybe try this one and pause before I do it, and then see if you are able to do it as well. I'm actually going to flip this. I don't know why I scooted over then, because I'm actually going to flip it, which is totally fine. I'm going to go y equals x squared minus 2, and I'm going to minus y equals negative x plus 4. It just is going to keep this as positive so that I don't have to worry about that. So this is going to become 0. X squared is just x squared. I'm going to get plus x, and then I'm going to get minus 6. I can still factor this. And so I'm going to get x minus 1 and x plus 6. Nope, that's not right. I don't know what I was thinking. Minus 2 and x plus 3. There we go. That would be 5 if I wanted 5 there. Right, so if I multiply these, they get negative 6. If I add these together, I get positive 1. So x minus 2 equals 0. X plus 3 equals 0. I get plus 2 here, so I get x equals 2. And I get minus 3 here, so I get x equals negative 3. So check how you did. So these would be considered our solutions. What if they asked us for the actual points, though, too? So if they asked us for the actual points, we would need to then find our y's by substituting these in. It doesn't matter which one you substitute them in because they're solutions for both of them. The linear function tends to be a little easier, but it doesn't really matter. So I'm going to show this to you so that if it asks you, like, where is the point, then we would need to know what our y's are, right? So what I'm going to do is I'm going to go negative, and I'm going to plug in 2 plus 4. Well, negative 2 plus 4 gets me 2. And then I'm going to do it again with the negative 3. So I'm going to go negative, plug in negative 3. I got to double it, right? Plus 4. That gets me 3 plus 4, and I get 7. And then I would have my points. 2, 2, and negative 3, 7. Okay, we can always check it here too. Like if I do, look, if I do 2 squared, that's 4 minus 2 does get me 2. If I plug it in here, negative 3 squared is 9 minus 2 is 7. So you can see it doesn't matter which one you plug it into. But sometimes they may ask you for what are the actual coordinates, not just what are the solutions, okay? So this is how you would find the coordinates. You'd substitute them back in. Like I said, the linear function's a little easier to do. But it doesn't matter because technically these are solutions for both, right? These are where they cross. So these are the solutions for both of these, so it doesn't really matter which one you plug it into. All right, so we can also then solve by substitution. Remember, that was one of our methods for systems. We had graphing, which we already did. We had elimination, which we already did, and then we can substitute as well. Now, for substitution, we take this, and see how it says y equals 20x? We'll see how it says y here. This becomes 20x. If y equals 20x, I can make this y 20x. So I would go 20x and then equals everything on the other side. Negative 2x squared plus 60x. And then we want to set it equal to 0, so I'm going to go minus 20x minus 20x. And we would get 0 equals negative 2x squared plus 40x. Now that we have this, we can start factoring and solving and things like that. So I'm going to factor out this negative 2. You always want to try to take out the negative as much as you can. So negative 2, because both of these divide by 2. And I'm going to take out an x. See how they both have an x. So if I divide this by negative 2x, I just get x. And if I divide this by negative 2x, I'm going to get negative 20. The x goes away, and it becomes negative because I divided by a negative. Now that I have it factored, I'm going to go negative 2x. Actually, I can do this down here. Hold on. I'm going to go negative 2x equals 0. Well, I divide by negative 2, and I get x equals 0. So there's one of my solutions. And then I'm going to go x minus 20 equals 0. Add 20, and we get x equals 20. So again, we have two solutions. And then let's practice plugging them back in and seeing what our y's would be. So I'm going to again use the linear function just because it's easier. So I'm going to go 20 times 0. Well, that just gets me 0. And then I'm going to do 20 times 20, and that gets me 400. And so I would say they're at 0, 0, and 2,400. So there we go. Those are the two places they cross. So the main things to remember is, no solution, they don't cross. I'm going to write intersection. One solution equals one intersection point. Maybe I'll put no intersection point, right? We're looking for a point. And two solutions means two intersection points. All right. So here's your independent practice. You can solve it any way you want. You can graph it, you can substitute, you can eliminate, you choose which method you want to do. But no matter what, we should all get them. I want you to not only tell me what the x's are, but I want you to tell me where they cross. What is the point? So you need to substitute is basically what I'm saying after the fact. So it should look something like this or like this. And in a sense, I'm going to skip that one, it should look similar to this, where you have not only the solutions, but the points, exact points that they crossed. Okay? All right. Adios.